Welcome back. Let's finish that last weak acid problem. All right, the problem that we did above, number 5, we worked backwards and we found the initial concentration. And I just wanted to point out, we did our check, okay? So I did my initial assumption that I could ignore the X, okay? And then I checked and it worked out perfect. But this example, I wrote it so that it is not perfect and we can't ignore it. So in this next problem, it would have come up to 44%. I just wanted to do a compare and contrast. So let's pretend I didn't know that. My equation is H4 goes to those two. My Ka is equal to there. And I look up Ka off of my reference sheet, and it's 1.7 times 10 to the minus fourth. All right, what do I know for the table? Well, I'm trying to find my initial concentration, but it doesn't say I added any of that, so I can fill in my change. And my final pH is 3.420, so my equilibrium pH, and 3.420 is equal to the negative log. Multiply both sides by -1, take the anti-log. So my proton concentration is 3.8 times 10 to the minus fourth. Don't forget to put your unit because that's a molarity now. I'm going to check it one more time. All right, that checks out. So this number is 3.8 times 10 to the minus fourth, and 0 plus x equals that. So x is also 3.8 times 10 to the minus fourth, which makes this one also 3.8 times 10 to the minus fourth. All right, so the initial minus x. I now have enough information that I can plug it into my equilibrium expression. So I know that 1.7 times 10 to the minus fourth is equal to 3.8 times 10 to the minus fourth squared, all over the initial minus x. All right, I'm going to start with, I'm going to ignore that and check it. My initial concentration turns out to be 8.5 times 10 to the minus fourth. Okay, now I can already tell we're going to have a problem because these have the same magnitudes. They have the same magnitudes, but I'm going to check. So 3.8 times 10 to the minus fourth divided by 8.5 times 10 to the minus fourth times 100. Ooh, 45%. No, that was a bad assumption. But the nice thing is, I actually know what X is, so I can just go plug X in. I could have done that in the first place, but sometimes it saves a little bit of math. All right, so in that case, I have to change the problem to this. I may not ignore that. So minus 3.8 times 10 to the minus fourth. So it changes my math. It's a little bit more complicated. Not a big deal though. Now, would you have known to check for that? No. Usually it's nice just to do the assumption, and if you have to go back and do the longer math. Okay, so now my math is 1.7 times 10 to the minus fourth times the initial minus 3.8 times 10 to the minus fourth is equal to 3.8 times 10 to the minus fourth squared. So I have 1.7 times 10 to the minus fourth initial minus 1.7 to the negative fourth times 3.8 to the negative fourth is 6.5. 6.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Check that again, 1.7. Yep. All right, is equal to 3.8 to the negative fourth squared. And that is 1.4 times 10 to the 1, 2, 3, 4, 5, 6, 7 to the negative seventh. Check that again. Yep. Okay. Now I have to combine like terms. So 1.7 times 10 to the minus fourth initial is equal to, I'm going to add 6.5 times 10 to the minus 8 to both sides. And I get 2.1 times 10 to the 1, 2, 3, 4, 5, 6, 7. To the 7. Do that one more time. And 2.1 times 10 to the 1, 2, 3, 4, 5, 6, 7. Yes. All right, now divide both sides by 1.7 times 10 to the minus fourth. And my concentration is equal to 1.2 times 10 to the minus 3. Check that again. Yep. Okay. So my initial concentration is actually 1.2 times 10 to the minus third. And I don't have a spot for that, but 1.2 times 10 to the minus third molar. And then I would subtract the 3.8 times 10 to the minus fourth off of that for my equilibrium number. So 1.2 subtract 3.8 to the negative fourth, and I get pretty much what I had earlier, but it's 8.6 with sig figs times 10 to the minus fourth. And then that one goes down, and that one goes down. All right, so again, it's the same setup. This math just didn't allow us to do that wonderful little shortcut, so we just had to do a couple extra steps in the math. All right, those are your weak acid problems. I hope I've done enough examples, kind of one of each kind, so that you can get through all of the handout on your own. All right, until next time, Jolly out.